This program will introduce you to some of the technical changes for 1988. We will look at the new features and systems found throughout the model line. The key features will be divided under the following major headings. Changes to the model lineup. Model 300 CE Type 124. AC compressor shut off, all models. Climate control systems. Supplemental restraint system. Continuous injection system, all models. Continuous injection system, California version. Radio operation. The Mercedes-Benz sound system. The 1988 model line has been expanded by the following: the 300 CE, the 300 TE, the 300 SE, and the 300 SEL. These vehicles are powered by the proven six-cylinder M103 engine originally introduced in 1986 in the Model 300E. The following models have been discontinued: the 300D Turbo, the 300 TD Turbo, the 300 SDL Turbo, the 190D 2.5 Turbo, the 190E 2.3 Sports Sedan. We will first address the differences related to the new four-passenger coupe, which is a development based on the Type 124 sedan. The front end section, including the radiator grille, hood, and front fenders, are identical to the sedan. From there on, beginning with the increased angle of the windshield to the modified trunk, all detachable body components are different, with the exception of a few small items. An adjustment that is somewhat different involves obtaining proper tension of the side windows. The seal provided by correct tension is important to prevent wind noise or water leaks. To simplify this adjustment, the in-out tilt adjusters for the front and rear side windows are accessible after removal of the lower trim panels. The panel is removed by pulling it to the rear and then out. The hex bolt adjusters are accessible after removing the rubber caps. The door glass adjustment is correct if, with the door sitting on the catch, a clearance exists up to approximately the middle of the window, as shown here. If an adjustment is necessary, the rear adjuster is turned in or out to tilt the rear of the glass. The locking nut must be loosened and held in place. A 5.5 millimeter socket is used to turn the adjuster. The door must continue to open and close properly. If not, tension on the front of the glass may have to be corrected at the front adjuster. Looking at the rear glass, the window must seal properly, but not so tightly that it pushes the door glass out at the top. The rear window tension is adjusted in a similar manner. Next, we will look inside the door. After removing the familiar hardware, the interior door panel is removed by lifting up. Further adjustments for the door window are now accessible, such as the front and rear upward limit stops, fore and aft tilt adjustments, and an adjustment which provides a means of pressing the window outward at the bottom to ensure proper tension at the lower window seal. Looking further, we find that the window regulators are fastened with 6 millimeter pop rivets. If the regulator assembly must be removed, the rivet heads are drilled using an 8 millimeter bit. A special pop rivet tool is available through the standard equipment program for installation. You will also notice that the inner door latch is cable operated. On reassembly, be sure to insert the cable collar in the correct slot in the keeper. It can easily be installed in the rear slot, which is incorrect, and the door latch will not operate properly. Looking at the windshield wiper assembly, the light alloy covering with the access flap used on previous models has been replaced with a one-piece plastic cover. This new version cover is simply snapped in place. The same blade assembly is used on the 124 Coupe and the 1988 model year 201 series. Although the rubber insert is the same length as used previously, the blade assembly mounting point has been relocated and is not interchangeable with the previous version. The 124 Coupe also uses an additional fuse for protecting the instrument illumination circuit. The fuse is color-coded red for identification. This change was phased in during model year 1987 on all models except the 107. The procedure for removing the radio in the coupe is somewhat different. First, remove the retaining screw and lift out the wood trim. The ashtray opens automatically after pressing the door. Slide the removal button to the right so that the tray can be lifted out. The two screws securing the ashtray housing are removed, and the housing is pulled out. The retaining clips for the radio are now accessible. Incidentally, if removing the radio on a Model 126 with the new sound system, you will notice this coupling amplifier. If the radio is going to be exchanged, this amplifier is removed from the old radio and attached to the new unit. The AC compressor shut-off is now controlled by a coolant temperature sensor instead of the previous temperature switch. Also, to prevent engine overheating, the AC compressor will now shut off in 2 stages. At a coolant temperature of 117 degrees Celsius, the running time of the compressor will be reduced by 50%. Cycling 20 seconds on and 20 seconds off. If the coolant temperature drops to 114 degrees Celsius, the compressor will again resume operating in the normal mode. But if instead of falling, the coolant temperature should continue to rise, at 120 degrees Celsius, the compressor is completely switched off. When the coolant temperature drops to 117 degrees, the compressor will again cycle 20 seconds on, 20 seconds off. A short in the evaporator temperature sensor will also cause the compressor to cut out. This will prevent the compressor from running continuously and eventually freezing the evaporator. The compressor will engage again only after the key has been cycled. A shorted evaporator temperature sensor having a value of less than 2,500 ohms will cut out the compressor. A major change for 1988 models involves the incorporation of onboard diagnosis in the climate control systems. The diagnosis is accomplished using this impulse counter, which translates diagnostic output in the form of a numeric code. To briefly explain the basic concept, faults in the automatic and tempmatic climate control systems are recognized by diagnostic circuitry in the push-button control unit, computed and sent in the form of voltage impulses to terminal 7 of the test connection. These voltage impulses can then be read with the impulse counter. To perform the test, the counter is connected to the test plug. You will recognize this plug as being the same test plug used for testing the EDS system on previous diesel models. The ignition switch is turned to the run position. If the tester is functioning and the current supply is correct, the battery LED will illuminate. You may then proceed with the test. Press the button for no less than 2 and no more than 4 seconds. If the number 1 appears and locks in, there are no faults in the system that are present at this time, or that can be detected by the diagnostic circuitry. If there is a fault in the system, the tester will continue to count. When the tester stops counting, record the number. After a few seconds, which allows the tester to reset, press the button again for 2 to 4 seconds. If there are no further system problems, the first fault code will reappear. If there is a second fault, the tester will continue to count and stop at a higher number. Although numbers ranging up to 62 may appear, only 23 numbers are presently assigned a fault code. Continue this procedure until all faults are identified and recorded. When there are no further system faults, the first impulse readout will reappear. Each number refers to a particular malfunction source and is listed in the troubleshooting chart found in the 1988 Model Year Introduction book. As we saw during our test, fault number 3 appeared first. Looking at the troubleshooting chart, fault number 2 or 3 identifies a problem with the in-car temperature sensor or circuit. The first test required to confirm the source of the problem is identified as using an ohm meter to measure the resistance value of the in-car temperature sensor. The values specified for a good component and the correction are found in the last 2 columns. You will find that all test programs included in the 1988 Introduction Manual are arranged in this new format. Incidentally, a wiring diagram is included at the end of each test program for quick reference. There are a few additional important points which must be emphasized. First, the impulse readout for the climate control systems will only indicate a malfunction which is present at the time the test is being performed. It does not record intermittent problems as there is no memory feature. Also, the tester will only detect a totally short or open circuit. In other words, if the impulse readout shows no malfunction but a complaint exists, a component tolerance deviation may exist. For example, a low resistance value at a sensor. Therefore, if the fault is not indicated by the impulse readout, the complete system must be checked using the socket box tester and a multimeter. And a final point regarding the climate control test. You will notice that during the impulse readout, the LED in the fresh recirculated air switch will blink. The blinking is of no significance for test purposes. As of model year 1988, the supplemental restraint system now incorporates a control unit with energy accumulator, voltage converter, and crash sensor integrated in one housing. This single unit eliminates the previous separate components and is mounted in the same location as the previous crash sensor. The new SRS control unit monitors its own internal circuitry as well as all system components. When the ignition key is turned on, the SRS warning lamp in the instrument cluster illuminates for approximately 4 seconds while the control unit runs a test cycle. If the system is fully operational, the warning lamp goes out. A problem is present in the system if the SRS warning lamp does not light, or if the warning lamp stays lit. The cause can now be diagnosed by a blink impulse readout provided by the SRS warning lamp. In fact, because of changes to the components and operating characteristics of the system, the test adapter previously used for diagnosing SRS cannot be used for testing 1988 model year vehicles. To obtain diagnostic information using the SRS warning lamp, Terminal 1 and 6 of the test connection are connected to a jumper cable. To initiate the diagnostic test, the ignition must be on and the jumper button pressed for 2 to 4 seconds. This will cause the SRS lamp to blink out a diagnostic code. If the lamp blinks once, there are no faults in the system. If the lamp blinks more than once, observe and record the number of blinks. Then, check to see if another fault is present by again pressing the jumper button for 2 to 4 seconds. If no other faults are present, you will see the same number of blinks again. If there is a second fault, the blinks will continue to count and stop at a higher number. Repeat the procedure until all faults are recorded. The test procedure is facilitated with the use of the impulse counter, which eliminates the need for counting blinks. The counter leads are connected to the test plug as explained in the introduction manual. When the power input is connected, the LED will illuminate to indicate that the voltage supply is correct and the tester is functioning. With the ignition switched on, press the start button for no less than 2 and no more than 4 seconds. A number from 1 to 10 will appear. The number 1 indicates that there are no faults stored in the system's memory. Numbers 2 through 10 relate to a particular fault in a component or circuit. Determine all fault codes by repeatedly depressing the start button for 2 to 4 seconds until the first fault code number is displayed again. The fault codes and corresponding detailed tests are found in the introduction manual. Performing further detailed testing requires the use of the socket box tester and an appropriate multimeter. To avoid possible injury and inadvertent deployment of the system, you must use only a multimeter with a very low resistance measuring current. The Sun DMM5 and Fluke models 23 and 77 meet this requirement. The SRS has a hard memory feature, meaning that disconnecting the power supply will not erase fault codes stored in the memory. Erasing must be done as follows using either a jumper button or impulse counter. First, you must recall the fault code. After the fault code is displayed, push the impulse counter or jumper button for 7 seconds. If you should mistakenly exceed 8 seconds, a false code 9 will be programmed into the system. It must then also be erased. Each fault code in memory must be erased one at a time in the same way. An exception is fault code 10, which is the code indicating an SRS deployment. Code 10 cannot be erased from memory in the control unit. Therefore, the control unit must be replaced after each SRS deployment. Modifications have been made to the continuous injection system, the majority of which relate to all engine types. We will first review the more important changes that are common to all 4, 6, and 8-cylinder engines. There is now a federal and California version CIS-E system. New control units are used, which are not interchangeable between the federal and California version. Looking further, we find changes that relate to specific models only, such as the installation of the familiar Hall effect sensor on all 4 and 6-cylinder models. This now provides the speed input signal to the CIS control unit. The V8 engines incorporate certain changes, such as the elimination of the control valve for exhaust gas recirculation, shown here on a 1987 model. An important change also related to all V8 engines is the adoption of the same procedure for measuring the lambda on-off ratio as used for the 6-cylinder engines. The idle ratio and ratio at 2,500 RPM are compared and must be within plus or minus 10. A detailed explanation is included in the introduction manual. There are 3 changes that relate to California version engines, and it must be emphasized that the following information is only applicable to California version vehicles. The first change applies only to the V8 engine and is the addition of a temperature sensor in the EGR pipe. The sensor measures the temperature of the recirculated exhaust gas and sends the appropriate signal to the CIS-E control unit. A 4-pole temperature sensor is a new development and is installed on all California version engines. The plug can be inserted in any orientation. The final change applying to all California version engines is the addition of an onboard diagnostic system with memory, which monitors all emission control components that either provide input signals to or receive output signals from the CIS-E control unit. The diagnostic circuitry will illuminate the check engine warning lamp when a problem is detected. The onboard diagnostic system is then used to quickly determine the faulty component or circuit. The key feature of this diagnostic system is the ability to initiate a test by simply pushing a button provided for this purpose and reading a blink code. The number of blink impulses, which may be as high as 12 for a V8 engine, are listed on a diagnostic table with the related fault. Detailed testing, if required to determine the exact cause of the fault, is done using the socket box and a multimeter while referring to the test in the introduction manual. An important point regarding the CIS-E blink code system is that the memory for storing intermittent faults is a soft memory. Therefore, before disconnecting the battery, control unit, or overvoltage protection relay, you must determine all fault codes. Any interruption in the power supply will erase the memory. And conversely, if repairs are completed without disconnecting a power supply, the memory must then be erased by disconnecting the battery for at least 5 seconds. On California vehicles, you should also refer to Test B in the introduction manual before attempting to check the adjustment of the on-off ratio for lambda control. The information in Test B is important since it explains the procedure now necessary to cancel the diagnostic signal and initiate the lambda frequency signal. This must be done before an on-off ratio reading can be taken. As noted in Test B, to cancel the diagnostic signal and initiate the lambda signal, you must first press the test button for 2 to 4 seconds. If no fault codes are stored in the system, the LED will blink once. If the LED blinks more than once, do not proceed with a lambda on-off ratio test. You must first correct any problems that are present in the system. When there are no problems and only one blink is observed, you may proceed by pressing the button again for 2 to 4 seconds. The CIS-E control unit is then programmed to send the on-off ratio signal. It is important to remember that every time the key is turned off and back on, the lambda signal is canceled and the diagnostic signal is again locked in. The procedure has to be repeated to provide the lambda signal. Returning to 1988 Federal version engines, it should be mentioned that diagnosis remains unchanged from 1987 models. Problems are still diagnosed using the on-off ratio tester. You should be aware, though, that once a fault is detected by a fixed on-off ratio reading, Test C in the 1988 introduction manual can be performed to locate the exact cause. The Becker radio has been redesigned for 1988. The new model is the Grand Prix Electronic 780. The following are some of the new features. motorized cassette loading and ejecting, music scan for cassette operation, scan and sync functions for the radio, left and right balance control. When using a cassette tape, the music scan feature is activated either forward or reverse by pushing the forward M button or RM reverse button once. The tape then moves to the beginning of the next music track. By pushing the M or RM button twice, fast forward or reverse is obtained without the music scan feature. When listening to AM or FM, pressing the button labeled Scan will program the radio to monitor a station for 5 seconds before advancing to the next station. To stop scanning and hold a station, press the button again. Pressing the button labeled Seek will automatically tune the radio to the first station within its reception sensitivity. It is now possible to control the balance between left and right side speakers. To do this, first press the function key. You can now favor either side by pressing the bass or treble buttons. The display will indicate the balance by showing a number and an arrow. To return to a neutral position, push both buttons simultaneously. Be sure to remember this feature in the event of a customer complaint of no output from the left or right side speakers. The Mercedes-Benz sound system is standard equipment on the SEL and SEC models. This system was developed specifically for the interior acoustics of each model. Therefore, the dashboard speakers, door speakers, and amplifiers on the coupe and the sedan are designed for each model and should not be interchanged. A speed-dependent volume control is also new. This feature will adjust the volume slightly as the vehicle's speed changes. The speed signal is taken from the electronic speedometer. The Mercedes-Benz sound system consists of the following: the Becker Grand Prix Electronic 780 with amplifier coupling, left and right amplifiers, which are dual amplifiers located under the rear seat back. The left amplifier serves the left side speakers, and the other serves the right. Each side provides a power output of 50 watts per channel, for a total output of 100 watts RMS. The speakers located in the dashboard, hatch shelf, and front doors. And a new high-impedance fader switch identified by a white dot and a yellow base. Only some of the key points of interest related to the 1988 models have been briefly covered in this program. For more complete information, refer to the preliminary edition of the Model Year 1988 Introduction Manual. Your dealership has received 1 copy. The final edition of the Introduction Manual will be sent to each dealership in the near future. When received, dispose of the preliminary edition. Pre-addressed mailing envelopes and order forms are included with this program for the convenience of those wanting their own copy of the 1988 Model Year Introduction Manual. This concludes our review of the 1988 Model Year Introduction. An Education for Excellence service training program.